Alright guys, part 2, chain rule. So we're still on 3.4. 3.4. The chain rule, part 2. Okay, I'm going to start us off with an example that just uses the chain rule to just a refresher before we move on to something fresh. So let's say that I ask you to differentiate the following. And the function is f of x is equal to x squared times the square root of 1 minus x squared. Cool? Alright. Any suggestions of what I can do here? Jada, what do you think, man?
F of x be x squared root of 1 minus x, and then g of x be x squared.
Okay, so you're trying to break it up into two. Now here's my question. I see what you're trying to do here. You're trying to locate a chain rule. The problem is that there's way more than just a chain rule here. I want you to look at this. I have something times something, which means I have a product. I have this times that. So I'm going to have to use a product rule. Can we start there? Agreed? Okay. Now, one thing before I even start this problem, anytime you're dealing with roots, rewrite them. Make your life easier. Okay? Alright. Ready for the product? Yes? Okay, so you tell me you just took a quiz over the product. What do I do? So derivative of what? The very first one, right? So 2x times what? 1 half, right? So derivative of the first one times the second, then what? Plus, leave this one alone, right? So x squared times the derivative of the second one. Do you realize how this is a chain rule? Just that by itself, this right here will be a chain rule. Can you see how you have an x to the 1 half technically? And then on the inside you would have the 1 minus x, right? So how do I take care of that with the chain rule? So bring the 1 half to the front, right? So times 1 half, and then what? We're going to leave what's on the inside alone, and what are we going to do to the power? So it becomes negative 1 half, and then what? Times the derivative of what? The inside of the function, right? Which in this case would be negative 2x. And you've derived this thing. You've got to clean it up. Where did the negative 2x come from, guys?
From g of x. We use the chain rule.
We use the chain rule. This is your function that's on the inside, okay? Remember, guys, and everybody, I'm going to be honest, you walked out of here last class thinking you knew the chain rule, and I'm judging from your looks, you're super lost, and you're like, I don't know what is happening again, okay? I told you, the chain rule is going to take you some time to take used to. Okay, the chain rule says that if you have a function inside of a function, notice how I highlighted the 1 minus x squared. That's your function that's on the inside, okay, right? To find the derivative of that, you would take the derivative of the outside function. You leave the inside function completely alone, times what? The derivative of the inside. What's that? Yes, sir.
So you're using the power rule on the first one.
Yes.
Ignoring whatever's inside, keeping whatever's inside the parentheses.
Correct.
And then whatever's inside the parentheses, you find the derivative of for the next.
Correct. Yes, sir.
Is there a chain rule formula?
Yes. Alright, this is going to take you practice, guys. And we can sit here as a class here after the video and just work and work and work and work. Okay, it's all about practice. Okay. Alright, can we clean this up? F prime of x. This right here is the same thing as 2x over the square root of 1 minus x squared. Agreed? Oh, I'm sorry, it's positive, right? Sorry. My bad, I thought it was a negative. Scratch that, sorry guys. F prime of x, so that one is positive, so I'm just going to leave it alone for the moment, right? So 1 minus, I'm just going to leave it like that. Cool? Now this, I do got to clean up a little bit. Okay, this 2 right here is going to cancel out this 1/2. Agreed? This x squared right here and this x will make it an x to the, this x squared and this x right here will make an x to the third, right? But it will be a negative, right? So negative x to the third. Agreed? Okay, so I've taken care of that, I've taken care of that. And this, the fact that it's a negative, tells me that it's a square root on the denominator. Cool? Personally, if you want to clean it up after this, I mean, I wouldn't do much, but the only thing I would try to do maybe if I were you is try to get the same common denominator. So instead of having 2 fractions, I'll have 1. So in order for me to do that, I need to multiply this one by the square root of 1 minus x squared. Agreed? So what I do to the bottom, I need to do to the top. So that will become 2x times 1 minus x squared minus x to the third power. Agreed? F prime of x would then be 2x minus 2x to the third minus x to the third over the square root of 1 minus x squared. And finally, what is f prime of x? 2x minus 3x cubed over 1 minus x squared. I guess that was a rough chain rule to start with today. We forgot the chain rule. Do I need to do an example of a basic chain rule? Like, be honest, otherwise you're going to be lost for the rest of today. Do I need to go back and do one very simple chain rule? Yes? Okay. Alright. So one very simple chain rule. Very, very, very simple, okay? So let's pretend that you have f of x equals, I'm going to make this very easy, 2x plus 1 to the third power. Okay? Very easy, simple one. Cool? Do you see how there's a function inside of a function? Yes? Now, I'm going to show you how to do this problem 2 ways because I feel like some of you guys are going to benefit out of this. It takes longer, but as long as you understand, do it. Okay? The rule says that you have d derivative in terms of x of f of g of x would be equal to f prime of g of x times the derivative of g of x, right? So g prime of x. Agreed? Can I break this up into 2 functions so that it can help you out maybe? Yes? So, can I say that f of x would be x to the third, right? And then can I say that g of x would be 2x plus 1? Agreed? Yes? Do you guys see that? Differentiate those both. Just what's f prime of x right here? 3x squared. And what's g prime of x? 2. Agreed? Okay. I have this individually and I'm going to go back. If you really memorize this, you should be good to go, right? Okay, if this is f prime of x right here, agreed? What would f prime of g of x be? What is it asking you to do? Okay, if you're a little confused, you ready? I'm going to simplify it even further. I'm going to go back to like algebra. You ready? If I have f prime of x and I ask you for this, what are you going to do? You're going to plug in 2 into x. What is this asking you to do? Plug in g of x, right? So what is that going to look for us now? 3 times 2x plus 1 to the square, right? It's right here, right? Agreed? And then we already have g prime of x, agreed? Which is 2, right? Do you guys now see how this part would be this part would be this, and now we can just put it together. Therefore, what's 2 times 3? 6 times 2x plus 1 squared. In my personal opinion, that confuses me way more and it leads me to make more mistakes than if you try to do this from the beginning. Look, check this out. Bring the 3 to the front. Agreed? The power subtracted. Agreed? So notice how we have this square right here. And then what's the derivative of the inside? And the 2 times the 3 became the 6. If you can handle that at all in one step, do it. If you need to break this up into functions, break it up into functions until you're used to it, and then you can do it all at once. Okay? Alright. Got one more algebraic, heavy algebra. Okay? Before we move on to trig, because I got to talk about trig with the chain rule. Okay? So f of x equals to x divided by the cubic root of x squared plus 4. This will be a quotient and a chain. Right? Can we all see that? How this is a quotient? Right? Do you recognize where the chain will be located? The denominator. Agreed? Okay. How can we make this problem a little easier from the beginning? Okay. There's two options here. First of all, anytime you're dealing with any type of root, get rid of the root and write it as a power. Okay, we can do that. So instead of having x over the cube root of this, we can have x over x squared plus 4 to the 1/3. We can do that and we can still use the quotient rule. So Hale is suggesting, what if I rewrite this as follows? Is that the same thing? Do you guys agree? Do you have to use the quotient anymore? Now you can use the product. My personal opinion, it's a lot easier to use the product, personally. Doesn't mean it's easier, I personally I feel like it's faster. So are we okay with what I did here, and can we use the product here? Yes? Okay. So f prime of x, one more time, tell me what to do.
Take the power and multiply.
We can't do that yet, hold on. What are we doing?
Do you do one before the other? Meaning you do the chain rule, then once you get whatever the chain rule is, then you do the product rule?
No, you gotta follow. So what's happening here? Do you see how you have this multiplied by that? That takes priority. So that means you have to do the product. Okay? You can't just start doing the chain rule here. You gotta start with the product. You ready?
Wait, why can't you do like -1/3?
We can. I just suggest that you stay organized from left to right. That's just my suggestion. So if we go from left to right, we'll start with the derivative of this. Alright? So what's the derivative of x? 1. Times what? Whatever you have there, agreed? That's what the product rule says, right? Derivative of the first one times just the second one. So, x squared plus 4 to the negative 1/3 power, right? That's half of the product rule. Then he tells you to do what? Plus, what? Leave the first one alone, and now multiply by the derivative of the second one, which now you realize that it is a chain rule. Okay? Agreed? The only way I can derive this thing right here is by a chain. So I'm going to multiply by a chain rule, so I'm going to give myself some space there. How does the chain rule look on this one? Negative 1/3 times what? X squared plus 4 to what power? Negative 4/3. Times what? The derivative of the inside. Very good. Doesn't look pretty at all, but I know that you're more than capable of cleaning this up. So this first part looks like 1 over the cube root of x squared plus 4. Agreed? Okay, so now I have plus negative 2x squared over 3, right? Third root of x squared plus 4 to the 4th power. And I'm going to be honest with you, I'm not going to mess with that, and I'll just leave it like that. There's no reason for me to try to get fancy here. I would favor for you to, instead of having a plus, you'll put the minus out here, right? You okay? Yes? Okay. Yes, sir.
Put in x, or do you have to switch it back to the root instead of putting it in the power?
Say that one more time.
So you have like, at the beginning you switch the root 3
To the 1/3? Yeah, you don't.
answering, do you have to put it back?
Yes. So, two things that you will not see on the test and you're going to get used to is you will not see powers that are fractions, and you will not see negative powers as in the answer. So notice how I got rid of all the fraction powers and I wrote them as a root, and anything that was negative you brought it down to the denominator. Cool? Alright. Are we sort of okay? Alright, so then we're ready to move on to trig then. The chain rule with trigonometry. Okay? So here's the transcendental functions. Okay, so let's say that you have f of x equals to the sine of 2x. We're going to start out with one that's very easy. Now, you're typically not going to have parentheses there. I put the parentheses in there to help you out a little bit. Do you see how this is a function within a function? The inner function would be 2x, and the outer function would be sine x. Do you now see how the chain rule applies here? Okay, the chain rule tells you, take the derivative of the outside function first. What is your outside function here? Sine x, right? What is the derivative of sine? Cosine. Do not do anything to the inside. Leave it alone. So cosine 2x. Then what do? Multiply by the derivative of the inside function. So in this case, it's going to be 2 cosine 2x. Cool? Alright, let's try another one that's just basic. F of x equals cosine of 5x. Cool? Just basic. F prime of x. What is the derivative of the outer function? Negative sine, and it's going to stay with a 5x. Agreed? Times what? The derivative of the inside, so it's going to be negative 5 sine of 5x. Cool? Alright. One last one. You'll do this one on your own, and then move on. Bless you. G of x is equal to secant, bless you, of 3x squared plus 1. Secant of 3x squared plus 1. Alright, if you're watching the video, go ahead and check your answer. I'll explain it very quickly. So the outer function, it's secant. We know that the derivative of secant is secant tangent, right? But typically, when you just had the parent function of secant x, it was just secant x tangent x, right? But you don't have that parent function. You have this on the inside. So you got to make sure that you keep that same thing on the inside. And because this is a chain rule, you got to multiply by the derivative of what is on the inside in this case. So the derivative of 3x squared plus 1 would be the 6x. All I did was just bring it up to the front so it doesn't get confusing. Cool? Alright. Moving on to our next function that we got to talk about. And this is the following. The natural base. So if we talk about the derivative in terms of x of e to some power, so the natural base, right? You guys remember that one? That is going to be equal to e to the u times the derivative of u. Okay? E to the u is equal to e to the u times the derivative of u. Yes, sir.
Oh, I should say, why are you using that?
Because it doesn't always have to be x. Think about it, like what if it has x squared plus 1 as the power? You see what I'm saying? Like I could just have e to the x, but that would just be the parent function. But what if I have e to the x squared plus 1 or e to the 1/2 x or e to something else? So the reason why I don't do that is I want you to think about it. We'll start. That was going to be my first example. So example 1. Let's say that f of x is equal to e to the x. So if you're going to do the derivative of this, it's always going to be whatever you have exactly how it is, so e to the x, times the derivative of the power, which in this case is 1. So the derivative of e to the x is itself. Cool? So times 1, so it's e to the x. Make it a little bit more complicated. So f of x is equal to e to the 3x. What would f prime of x be? E to the 3x times the derivative of the exponent, which in this case is 3. Cool? Are we okay, or do we need more examples with the natural base? We're good? Alright. I'm going to give you a little break, because I'm about to then combine now natural base, trig, and chain rule all together. Okay, we're ready to go? We don't need a break? We're good? Okay, well then let's do this. Guys, the moment you get lost, stop me. Okay? F of x is equal to sine to the third power of 4t. I'll give you a break. I won't use the natural base. I'll give you a break. Okay. Which strategy to use here?
Use product rule or sine? Times sine times sine?
Would it be what? Oh, I'm sorry, f of t, yes, good catch. F of t, my bad. F of t is equal to sine to the third power of 4t. What rules do you see here? Product where? I only see chain. Why product? Let me make sure I clarify that. How do you see the product here?
You could do sine times sine times sine, but since we don't
Oh, I
have
see what you're
sine-
saying. Ooh, I see what you're saying. So he's like, hey, well, how about we rewrite this as sine of 4t times sine of 4t times sine of 4t. That's game, right? Take it from there and you can do product. Fantastic. Wouldn't be the best strategy for this problem. Zach mentioned that you see the chain rule. If you don't see it, maybe it will help you if you rewrite it as this. Because that's technically what this is. Agreed? Or did you guys know that? Did you guys know that we place the power here because people would get confused that this meant 4t to the third rather than the sine? That's the reason why, I don't know if you noticed with trig, we always put the power by the word, right? Sine, cosine, tangent. Is this more obvious now that this is a chain rule? Yes? Okay. So we're going to start the process out. You tell me what I do first. Bring the 3 to the front. So 3. Then what?
Leave sine 4t.
Leave whatever I have on the inside alone. Agreed? Then what? The power comes out to be 2. Cool? That's the first part of the chain rule. Then what do I have to do? The derivative of the inside, right? Okay, the derivative of the inside. Wait a second. It's another chain rule. Sine 4t. Do you guys see how there's 4t inside of another function? Okay. Have I lost anyone? Do you understand how this right here, oops, I'm sorry. This right here will be another chain rule. Okay? So you ready? So if I'm going to apply the chain rule here, that's why I left myself a whole bunch of space.
So it's going to be cosine
cosine
Of
of 4t
Oh, never mind.
times what?
Times, oh,
The derivative of, now, it's like I'm only looking at that. The outer function is sine, right? The derivative of sine is cosine, and then now your inner function is 4t. The derivative of 4t is 4. So it ended up being not that terrible. Therefore, if I clean this up, f prime of t is equal to what? 12 sine square of 4t cosine 4t, and I'll leave it like that. Okay? How we doing? Yes, sir.
So the outside function on the second one becomes sine.
Yes. Yes, sir. Cool. I like to think of the chain rule like an onion. Think of like an onion. It has layers. Okay? So think as you're going to the core of the onion, or that you're going layer by layer. That's how I think about it when I first learned it. Okay? All right. Are we okay?
you have
Fantastic.
one with 4 layers.
I don't want to do that. Okay. Okay. So we're gonna pause for a moment of what we're doing here with the chain rule, and now we're gonna move on to natural logarithms. So we talked about the natural base, right? So e to the x. So we can now talk about the natural log, which would be ln, right? So that would be the derivative in terms of x of natural log, and again I'm going to use the letter u. Okay, so u could be anything. That would be the derivative of whatever you're taking the natural log of divided by whatever you're taking the natural log of. That's it. So literally you take whatever it's in here and you put it in the denominator. You take the derivative of that and put it in the numerator. Okay? So, example number whatever we're on. So number 1 for this one. G of x is equal to the natural log of 3x. Cool? Natural log of 3x. What is g prime of x? 3 over 3x, but that simplifies to be what? 1 over x. Right? I'm sorry? The problem, if they give you this problem, it will be stated what the domain is. What would the domain for this have to be? The restriction. X would have to be what? It has to be what? Greater than 0. You can't have negative numbers on a log, and you can't be 0. Right? I mean, that would be given to you on the problem. You don't have to worry about that. So that's a good question. On the test, like, you don't have to be worrying about, like, finding the domain. Like, you don't. It'll be given to you, or they know. Right? They'll know, okay? So you just focus on the calculus of it, okay? All right, next one. F of x equals to the natural log of 3x squared plus 2x minus 1. What is f prime of x?
6x
6x
2
plus 2
over that whole
over that entire polynomial there. If you wanted to factor out a 2, but I don't see how that's going to help, right? It's not going to cancel out. I would just leave it like that, right? Okay, last one, because I feel like natural base and the natural log are really simple. Let me make sure that you can practice it when it's more than just the natural log. So, g of x is equal to x times the natural log of x. What rules apply here? Product and then the natural log, right? So we have a product. Go in order. Okay, so the derivative of x is 1 times the second one, right? Plus x times the derivative of ln x, which is 1 over x. Agreed? Which cleans up to be what? Ln x plus 1. Okay, guys, I'm gonna go on a side note. So thank you for bringing this up because I was actually going there in a second, but we can't do what you suggested. But let me make sure that you understand. Do you guys remember that there's properties of logarithms that tells you that if you have something in front of a logarithm, that's technically the power. So he's saying I could rewrite this as natural log of x to the x power. Do you guys remember those properties? Okay, I'll refresh them with you here in just a second. Well, he's suggesting, could I then just do this? And the derivative of this, he told me to use a power rule, and we can't do that. You can use a power rule when the power where is an actual variable. So that would mean like saying x times x to the x minus 1. That looks funny, right? So we can use a power rule when the power itself is a variable. The power rule is only applicable when it's like x squared. So yeah, you can bring the 2 to the front, and then you would have 2x, right? But we can't do it when we have a variable there to try to bring it to the front. So this we can do. However, the fact that you brought up these properties, that's where I was going next, because actually those properties can help you a lot in calculus. Because you can have very, very complicated problems to solve. For example, this. What if I told you that f of x was the natural log of x times x squared plus 1 squared divided by the square root of 2x to the third minus 1. Now, this seems rather ridiculous. I'm doing it on purpose just to show you. Okay. You know how to do the derivative of a natural log, right? It's you would write the entire thing under the denominator there, right? The denominator, and then you would take the derivative of this mess, right? And that would be your numerator. I'm looking at this thing and I see a quotient, I see a chain rule, I see a product. I don't want to do all that. We can. You can. You're going to waste a whole bunch of time. However, what do you think?
You do ln of x times whatever, the numerator minus ln.
Okay, remember that when you have logarithms, you can expand them. We can rewrite this as the following. The numerator, so natural log of the numerator, minus natural log of the denominator. Do you guys remember that one? Yes? Okay. Now this became a little easier, but we can make it even easier. Pranav, what you got, man? We can actually break this one up too, because multiplication you can break it up into addition. Okay, very good. So f of x. All I've done, I haven't done any calculus, guys. This is just algebra. So ln x plus, now he said the following. Let me see if you follow me. 2 ln x squared plus 1. What did I do there? The power comes to the front. So can I go ahead and do that over here as well? So minus 1/2 ln 2x to the third minus 1. Yes? Now we're ready to do calculus, because now this problem became a piece of cake. Agreed?
Wait, so when you add functions together, you add the derivatives together?
Mm-hmm. Yes, sir. So here we go. F prime of x. Ready? What's the derivative of natural log of x? 1 over x. Plus, what's the derivative of 2 natural log of x squared plus 1? So 2 times 2x over x squared plus 1, and we'll clean it up here in just a second, minus 1/2 times what?
6x squared
Over.
2x cubed.
Agreed? This is a lot easier. Yes? Now we're just going to clean it up. I do not want you to combine all this because it's going to take us too long to do this. So I'm just going to say, I'm sorry, shouldn't this be 1 over x? Sorry, not a 1/2. The very beginning. I had it as 1/2. I was like, wait, that looks wrong. So it's 1 over x plus, I'm going to bring the 2 in, so 4x, right? Over x squared plus 1. I'm going to bring this in. So the 2 right here would cancel that one right here, the 6 right here into a 3. So it's going to be minus 3x squared divided by 2x to the third minus 1. and I will finish it there. Don't try to get common denominators and combine this into one. Okay? Do you see the value of logarithms and how properties of logarithms can help you out? Yes? Alright, we have about 5 minutes left, and we still need to talk about, well, we talked about natural logs, and we talked about the natural base, but not every logarithm has a base of e, and not every exponential has a base of e. What if we're talking about things that have, like, I don't know, log base 10, or 2 to the x power? There's got to be a way for us to differentiate that, right? So they have their own rule. Okay?
Next time.
No. We're finishing today. Here we go. Bases other than e. Bases other than e. Can you imagine? I used to take calculus 3, and it was 3 hours. I see some of you guys are already burned out, and we've only been taking notes for like less than an hour. My class was 3 hours, and I would just be like, oh my god, give us a break, dude. Alright, anyways, bases other than e. So here we go. If you have the derivative in terms of x of a function that has a base like this, other than e, right? So a to the x. It's actually very simple. You ready? You take the natural log of the base times whatever that you had, exactly like that. Okay? Times the derivative, so in this case of x prime. Okay? Okay. What if we have the logarithm base of a, and I'm going to switch it so it doesn't get confused. Can I go back to u one more time so we don't get confused? So if you want to go back here and switch it to u, maybe it'll help out so that you don't get confused. Okay? Alright. This one looks a little interesting. You ready? Yes, ln, natural log. So it's going to be a fraction, so it's going to be 1 over the natural log of your base. So in this case, our base for the logarithm is what? A. And you're going to multiply by whatever you were taking the logarithm of, which in this case was just u, right? Cool. Cool? And just like the one above, you're going to multiply by the derivative of that. So u prime. I know I've given you a whole bunch of information today. I know. Yes, sir. Yes. Yes. So example number 1 for this one, we're going to do something very simple. F of x equals 2 to the x power. Cool? Easy, simple one. What's f prime of x? Look at the rule. ln of 2 times what? 2 to the x times what? The derivative of the power, which in this case happens to be 1. Alright? So this would just be natural log 2 times 2 to the x. Alright? One more because I think we have some time. We have 2 minutes. We can do this. Let's say that you have f of x equals, and I'm going to combine them so that maybe logarithm base 10 of cosine x. Why not? Let's throw some trig in there. Okay. F prime of x. Okay. 1 divided by the natural log of what? The base, right? Which is 10. Times what? U for us would be cosine x. This entire thing is going to be multiplied by the negative sine x. F prime of x is equal to, well, if I have sine over cosine, what's that? Negative tangent of x times or over ln of 10. Alright, I know I have like a minute. I know you guys are dying to get out of here. if you were really overwhelmed today with this last couple rules, luckily for you, the AP exam doesn't really test much of this. Logs, like logarithms, they don't test much. I haven't seen a log in a long time, but I still like to show you because, I don't know, many of you guys will have careers that do have calculus involved in it. Okay? Please make sure that you do the homework, guys. We will talk about chain rule, finish up next class. Make sure that I answer any doubts that you still have. There is not a quiz next class.